of our thoughts and about agrivoltaics. Feel free to jump in if you have any questions. There will be time because I think I'll be about 20 to 25 minutes. So plenty of time for discussions afterwards as well. So feel free to jump in. So yeah, agrivoltaics, the greater than one experiment. I'll give all of you a little bit of an introduction about Lincoln University and the context of this topic. I'll go into what we are planning to do, and then there's time for Q&A. Land-based specialist university, and so in 2028 we will celebrate 150 years, and yeah, that's basically the only thing we do here at Lincoln is focus on the land-based sectors. We had an issue, and as a university and as a person, I like issues, I like problems. Because then at that moment in time, you create almost like the need for a solution. So Lincoln University decided or launched a sustainability plan. I would assume very much like Otago University has done as well. Carbon neutral campus by 2030, carbon zero campus by 2050. But as you can see, we were pumping a lot of CO2 into the atmosphere by using coal. Fifth largest user of coal in the Selwyn district, and that ended in December of last year when we switched the coal boiler off for good. And but before we came to that position, we did quite some work to actually get to that position. We started with load management. We had to figure out, okay, what are we dealing with when it comes to electrifying our campus, and what solutions do we have? What solutions are out there? And well, as you can see, if the graph on that I'm pointing out now with my pointer on the left bottom side, basically gives solar electricity production from all the different type of solar arrays that we were looking on. And as you can see, there is clearly a mismatch between where we have the energy production, where on the big graph there is actually the heat where we have the highest demand. So there is a mismatch. So how are we going to do that? So there were a lot of discussions to make sure that the students that we would close down over the winter period, and the students would be here during summer, and or start teaching 7 days a week, because at the moment you see all these little gray areas in between. Those are weekends or midterm breaks. But of course, that the human factor came into play, and that of course never materialized. So we basically came to a conclusion that we had to decarbonize, we had to electrify. Solar doesn't only work, but it's a good start. It's a good starting point. We thought about storage, and at the time currently we have decided that the grid is our storage, and that human behavior at that moment in time and at this moment in time is a step too far. So as a result, basically what we have at the campus at the moment, we are 100% certifiable renewable electricity, and we have electrified. So we've switched off the coal boiler, and bar a couple of areas where we need gas, for example, in the laboratories with the Bunsen burners and stuff like that, and some of our farm equipment. Basically, everything is electrified. How did we do that? It's a combination of roof solar. We're still grid connected, so we have sustainable, certified renewable electricity from the grid. Our solar panels on the roofs and on the side of buildings. We stimulate staff to actually come in and charge their vehicles on site. We were in the position that as a campus, we were quite damaged during the earthquakes. So we were actually in a position to rebuild the campus. That took some time to actually happen. I think at the beginning, when the earthquakes came, it was almost a bit mean that we had all these broken buildings, but not the money to actually rebuild. On hindsight, it was probably a good thing, because if we would have the money directly, we would probably have rebuilt exactly what we had, being the standard human behavior. But when time passed, we basically could build something that was future-proof. Hence the fact that we looked at air and ground source heat pumps, and we even pushed it further as well to actually put in our own agrivoltaics, or at that moment in time, just a land-based and our ground-mounted solar array, to give us approximately 20% of our electricity production that we would generate ourselves. The reason for that was, as I just showed you, was this load management. Because anything more than that 20%, we would have had to export in summer. And when we did the calculations, the business model didn't stack up. So hence the 20%. The cool thing is with renewable energy that it's modular. So if things change in the future, we can always add on. So then it would come to building a solar farm, and in the beginning it was just going to be a ground mount solar array, and then the actual discussion came, well, how can we just do that if we are a specialist university looking at the land-based sectors, and so we need to do something with the value of the land. So we need to create something, basically practice what we preach. So we need to become an exemplar there. But that's actually where our journey started, and because yeah, that's where the experiment actually started, and I'll come into it a little bit later on. Agrivoltaics. No, let me check with everybody. Sound okay? Speed okay? I see thumbs up. Cool. Thank you so much. So agrivoltaics, basically the definition is the value of creating electricity through the use of solar panels, plus the value of agriculture. We call that agrivoltaics. If you look at, and that's some work that I did together with a colleague of mine, Shannon Page. If we look at where are these solar farms going in, because everybody calls it a solar farm, but not necessarily the crops are defined except the electricity. The majority goes into class 2 and class 3 land. The reason for that is really simple, because it's flat. So when a developer comes in, it's basically a low infrastructure cost. They actually like that. And so if you then look at all the solar farms that are either consented or in consent, so this is all public information, we would have about 13,000 hectares of solar farms in New Zealand by 2027, the majority being on flat land. Do we really want to do that? The thing with agrivoltaics is that it is very much a cool discussion piece. So I talk to you, you talk to your neighbor, the neighbor talks to their neighbor, and suddenly there is magic going on. But we ask ourselves the question, is the research actually supporting that? The other thing that we looked at is, can the rural area play a role in this? So in other words, if we're looking at a future electricity system, should that be place specific or place agnostic? Well, research done in the United Kingdom basically showed that if you look at investment, energy savings, but also the wider social benefits, a place-specific system is really the way to go. Hence the fact that we think that agrivoltaics would fit within the rural landscape of New Zealand. We just need to be very clear where we need this when it comes to a supply and demand of electrons. One of the other things that actually helped as well is basically the cost of these renewable energies came down tremendously. So in other words, onshore wind and solar are very much into the mix and around that 5 cents per kilowatt hour. So yes, very easy to convince people to start investing in these areas. The other thing that we asked ourselves is, well, would there be social acceptance? And so we did a survey, and among the New Zealander, and basically we asked them, would they be in favor of solar in the rural space? And basically the majority said, yeah, we have no problems with it. We've asked the same when it comes to onshore wind, and the yes was a little bit less firm. It was about 75% of the respondents would have no problems with onshore wind in the rural space. So again, we see that there is definitely a social license there to start developing these systems. When we talk about agrivoltaics, I think we need to put two perspectives in our minds. One is, I think, and you probably got to get at it a little bit from the title of this talk. In marketing, we talk about synergies, and we say, oh, 1 + 1 is something equals something greater than 2. Well, within agrivoltaics, what we've seen so far in the research, that is not the case. So it's either going to be a compromise on the agriculture production, or it's going to be a compromise on the electricity production. We haven't found the sweet spot. I'm not saying that it's not there, but at the moment we haven't found it. So we have two different perspectives here. Either we use the solar panels to produce electricity, and that will be our primary focus, or we use solar panels to actually protect the crop from the elements. So when we talk about agrivoltaics, I think it's always good to figure out, okay, which perspective does the owner of the agrivoltaic system wants to put primary, and which one then automatically becomes secondary. In Germany, they go a step further. And so in Germany, they had the same issues with solar farms and renewable energy generation taking over land that could be used for production of food. So they came up with a very strict classification of what is an agrivoltaic system. The open system and the closed systems, and they would actually go down to very specific, like you would accept, what you would expect from the German culture, to be really specific in what they want, even to the fact that they basically have different categories. They look at which crop actually goes underneath, and they actually then make little drawings of how the systems would actually look. That has then been written into the legislative framework in Germany. So in other words, if you want to get consent to build a ground mount solar array, you need to start proving something to do with agrivoltaics. Then we thought, well, okay, if that's the case, because we are going to build this agrivoltaics system here at Lincoln University, and we want to produce electricity to decarbonize the campus. So for us, the primary purpose of that solar field is really clear. It's electricity production. So you could argue that what we did as a team of academics here at the university, we hijacked a decarbonization project belonging to the campus, and basically try to flip that into a research area where we can basically do whatever we want to do, as long as we don't impose on the electricity production, because that's what the university needs and wants. But then, okay, what system are we going to put in? Are we going to put in east-west tracking? Are we going to put in a fixed tilt? Are we going to optimize for winter sun? Are we going to optimize for summer sun? Which crops are we going to grow? Are we going to graze sheep? Are we going to do dairy? Are we going to do... So what are we going to do? Question mark. So we basically start asking ourselves, okay, what does the literature actually tell us? And is there a magic formula out there? This is one of the papers that was quite recent, done Northern Hemisphere, as you can see, Europe, where they compare different systems, and they basically come up with, well, 1x east-west tracking system or a west-east tracking system, depending on where you are in either northern or southern hemisphere, would stack up from an electricity point of view. But they basically said that the agriculture profit would be minimal with these systems. So what are we going to do? So then we looked at individual farmer experiments. And this is an example out of the Netherlands where a farmer actually replaced polytunnels, because previously their raspberries were growing on the polytunnels. They replaced those polytunnels with semi-transparent panels. To them, the crop, in this case raspberries, is leading. So they really want to protect that crop. For them, it is a sustainable solution by actually not have to replace the polytunnels, but are putting a more permanent structure in there, being the solar panels. For them, the electricity production is secondary. The quality of the raspberries is primary. They started off with a pilot in 2020. At the moment, they are full scale. So the whole farm is now covered in solar panels rather than in polytunnels. Then what you see, and again in the same country, this is the Netherlands, that now this is a pear orchard, that they are trying to do the same. So can we protect our pears against the elements? So again, here the crop production is primary purpose, and the electricity will be secondary. Then we actually looked at, okay, what is actually known? And one of our postdocs, Wei, he is leading this, and we basically did a meta-analysis up to 2025, and where we basically looked for peer-reviewed articles that would look at plant solar panel interactions. So we didn't look at what's the story with shading on plants. No, this was really plant solar panel interaction. What we found was 70 articles, 320 experiments, 20 countries. And as you can see on this, we're basically doing the last changes on the article. It has been accepted with minor changes. So I will forward the link to the article to Michael or to Natalie when we have it. Basically, what you see is the majority is in the Northern Hemisphere. But then if you see the amount of different climates that is being covered, it's humongous. You need to. So some of these researchers are using a solar array that has the size of 6 square meters, while others are using solar arrays that are 10 hectares. So the variation is in test setup and research setup is really huge. The variance in where they are, mainly Northern Hemisphere, but also over the climate zones, is really large. So what do we know, right? And remember, this is we are all doing this with the question: how should we design our own agrivoltaics farm? What shall we do, right? What do we need to do? Well, what do we know? Well, as I already said, most of it is Northern Hemisphere. There is no long-term monitoring or large-scale data available. So we still are looking at the validation of the stories that probably you and I hear as well about how wonderful agrivoltaics is. What we also see is that the performance underneath the panels or between the panels is site specific. And it also depends which type of crop there is and what in which geographic area the solar panel is being put. What we see is that a lot of these researchers basically almost retrospectively putting in the solar farm first and then putting in the plants. Even so that, and this is work done in the US, where they've actually looked at soil compaction, because you can imagine that if a solar farm developer is actually putting in a solar farm, they're only interested in putting the infrastructure in there as quick and as cheap as possible. Where when you look at crop production, you want to look at soil integrity as well. So therefore, if you want to establish a solar farm and you want to use the soil for agriculture, you need to make sure that you talk to your developer that there is no soil compaction while actually establishing the solar farm, because that soil compaction will actually give you reduced yields for years and years to come. But basically what we see is systems need to be customized per climate zone, per crop. And so what is your idea to actually get that productivity and efficiency and enhancements? A lot of people talk about the microclimates underneath the panels and how beneficial that they would be. And again, what we see in literature is that in certain climate zones, they are more beneficial than in others. What we do see, and the slides that I previously showed you about the example with the raspberries, there are definitely farmers out there that use those solar panels to protect the crops. So basically, what my postdoc came up with is basically said, well, listen, there's not a one size fit all, and basically whatever we're going to do, it is experimental, and so there is not a magic formula for an agrivoltaics system, and especially not in the Southern Hemisphere. So what have we decided on here at Lincoln University? So the status at the moment, if you would take a picture of the field, and I'll show it with you a little bit later, you just see an empty field. All the consenting has been done. And we will start construction of the farm hopefully by the end of this month, and it should be operationally early next year. So we're going for an east-west tracking system. We will have 2P set up bifacial panels. So what we actually have within, and remember what I said, right? Our primary purpose of this solar array is to produce electricity. So myself and the academic colleagues, we can do whatever we want to do as long as we don't exceed the shading envelope of the electricity production. So we need to figure out what's going on. So we're going to put a lot of sensors in there, because of course we want to know what's going on with the microclimate. We want to look at light sensitivity, etc., etc. Frost protection, another one. And I think we found one article that actually talks about frost protection and that actually described it in a peer review context. The rest is all hearsay. And so again, we really want to come up with a scientific basis on all these things. This is a site as we are looking at it now. So on the horizon, on the left-hand side, top left-hand side, you see Lincoln Township basically coming closer and closer to the university. On the right side, that's where the Lincoln University campus actually starts, and we're actually talking about this field down here. This is the same field from a different perspective. This is the artist impression. This is what we're going to do. We are going to put in high-value horticulture crops. What we're going to do is we're going to put in a vineyard, and the reason for that is that we already have a large vineyard on campus. All the academics are here. there's a lot of interest internationally about solar panels and vineyards, because apparently, and again, hearsay, we need to now start generating the data. Apparently, if we give the grapes the right amount of shade, there could be a higher sugar production, hence better wine quality, etc., etc. But again, we need to start producing the results. We're going to look at cherries. We're going to look at blueberries, but we're also perhaps going to look at annual crops like wheats or brassicas. If you're going to put in a solar array here, you're basically going to put a building on a piece of land. If you're going to put a building on a piece of land, you need to do something with stormwater, as if it rains, the water would fall somewhere else if you put solar panels on a field. But putting that aside, so that basically means we're going to put in a water retention pond, and that also becomes a biodiversity area. So what started as a decarbonization project now becomes a horticulture project, now becomes a biodiversity and ecological project as well. So you can actually see that there is a lot of interest from our academics to get actually involved in this project. Then we said, well, can we push it even further? You guys probably heard about my case with, I could argue, the second electric tractor in New Zealand, because the first one was actually built by a local guy here in Lincoln that actually converted an Izeki diesel with a leaf motor and a battery. We actually got ourselves an electric tractor, got ECA funding, and we're actually currently already using the electric tractor on the Lincoln University farms, not yet on the solar farm, but the whole idea is that when the Agrivoltaics, when the Lincoln University Energy Farm is fully operational, we will actually start using the electric tractor and actually run that farm as fossil fuel free. And you can see here, it is doing all the things that a normal tractor would do. And if you would ask the technicians who actually run the tractor, what do you think? They just say, it's a tractor. And of course, that's what you need and want when you run a farm. Looking at time, it's about 30 minutes that I talked. Just one more before I come to my conclusions. This is what I found recently in the news. And could this be a third perspective? Because we talked about two perspectives, like one, the energy production, the other one, the agricultural production. This is Lodestar's energy farm on the North Island at Bay of Plenty. And they sell this, or they market this as an agrivoltaics farm. But basically, they graze sheep there. They apparently, looking at the pictures, put it in the flood zone, but they constructed it in such a way that the farm actually survived. So they switched it off when the flood waters came. They switched it back on when the flood waters were gone. And guess what? The system worked. So just yeah, I thought a fun fact. So to me, and from our perspective, solar farms are currently being developed and installed in New Zealand, and we are not going to stop that. Simply due to the fact that the levelized cost of electricity is so attractive that there is a business model there. So whether we as an academic, as academics, or we as a social society are getting involved in that, yes or no, that is up to us, because I think the developers will push forward. I think dual land use, the way we look at it, and the scarcity of land being used for agriculture, I think we need to get involved. At least that is my position. And that basically means that we need to create novel research, because it is just not out there. And hopefully our farm will be part of that. That's my talks. I'm stopped sharing and I'm open for questions.
Thank you very much, Wim. Okay, so you hear me okay? So I'd like to open up the questions, so either online or in the room. Questions for Wim? So just quickly for me, while everyone starts thinking about what they want to ask, that example you showed of the floodplains, I guess I've recently had people ask me about that kind of sort of option. So basically, farmers who have some of their pasture that kind of regularly, when I say regularly, sort of a few times a year might flood. Whether they've been offered, I guess, the opportunity to build solar farms on those areas, and they're considering it. So I think it's kind of an interesting development.
Yeah, it certainly is. I don't know how feasible it is when it comes to if you need to finance it. Can you insure it and stuff like that. I've no insight on that, but I think the whole idea in using the lesser productive land to actually make it more productive by doing energy production, that would be beneficial. One of the things that we're doing at the moment in Canterbury and with Selwyn District Council is actually looking at a localized energy plan. So basically, again, looking at solutions in the rural space. Okay, if we want to keep the rural area alive, then energy will be a lifeline. The EDBs need to make a decision whether they are going to invest in infrastructure, place specific or place agnostic, i.e., will we build a nuclear power plant, or will we put in another hydro dam, or are we gonna put in humongous amount of solar fields, or are we gonna fill up the areas where we actually need that electricity? So that is a discussion that is at the moment top of mind. Luckily, the Energy Authority is thinking with us, because it requires some of the frameworks that are in legislation to become more flexible as well. So yeah, I think it's like I said, I think a lot of these things are still experimental.
So we'll go to Adam first. Get his hand up.
Yeah, thanks. So I guess my question is around your equation, 1 + 1 doesn't equal 2. Yeah, have you looked into, I feel like having a frame in a horticulture environment allows for easy implementation of robotics. Is there any application that you've seen with that, or have you thought about that?
Well, at the moment we have only one robot up and running within the university, and that is just mowing paddocks at the moment. I think robotics is a really interesting one, but the thing that is at the moment that is limiting plant growth is basically the shading of the panels. Yeah, interesting question, Adam. Answer is no. I haven't actually seen it, except for in certain areas in the US where they use robots to actually clean the panels. That is being done. The people that we do the solar array with, they basically say, well, you guys there's so much rain in Canterbury that we don't think that we would actually need that. So again, you tell me, question mark. Like I said, it will be an experiment.
Yeah, no, I'm looking at it more from, I guess, the harvesting side, and thinking of that solution to kind of fully automate the whole process of it. So, and having tracks and rails eliminates one of the big issues that you have of getting the robot out there, kind of thing. So.
Yeah, again, I think our solar array will be relatively small, at about 2.5 hectares. At the moment, we do everything in our vineyards manually. But it's really interesting. We've started the discussion with Agrivoltaics New Zealand, and basically opened up the discussion. Well, if there are companies out there, or even like the engineering department within either your university or Canterbury University or whatever. And yeah, we will have a testing ground where we are very open in collaborating and working with others, because like the quicker we can get the results of this experiment, the quicker we can actually advise and New Zealand what would be the next best step.
Yeah, it's another selling point to maybe get projects over the line. So thanks.
You're welcome.
So we've got a question in the chat from Jeff. He's asking about the winter-summer mismatch between generation and demand. I guess, do you have anything to say about the mismatch between supply and demand?
Well, I think it's a question I think that Sally Broker and myself got as well when we presented to Parliament. And I think the thing here is that people love to think in a one-dimensional singular solution for everything. I think what we're discovering, the more we look into this is a complex problem, and there will be multiple solutions out there. So I think we can only solve the mismatch between supply and demand by either doing two things. Either we need to change as human beings, or we need to embrace a multi-technology solution. And that multi-technology solution could be methane, could be wind, could be batteries, could be hydrogen, could be you name it, technology that has not even been invented yet. So I think we in New Zealand, we are at a really solid position, and we are ahead of a lot of other countries that are struggling with this, simply due to the fact that we have our hydro dams and our geothermal. So we could have basically start to look at this and basically start to think, how can we optimize that resource with cheaper renewable energy, rather than saying, well, let's keep our eyes closed and just let's everybody put in solar. Yeah, again, yeah, I think if Jeff, I don't know if that's enough, but yeah.
Yeah, so we've got another question by Sean, just about the social acceptance survey. He's wondering whether there's a difference between kind of urban and rural perspectives.
We haven't actually found that, and so because there was the results that we found were significant. We published this for the solar bit. We haven't actually found it. There is now one of our students, or one of Shannon's students, is looking into the Canterbury region. So far we haven't seen that within the New Zealand context.
And so another question online from Esther. Do you want to unmute yourself?
There we go. Hi, Wim. It's actually Ellen here.
Hey, Ellen.
I just had a question on it's probably not so relevant for you guys, because most of it's going to be labor, but the height of the panels above the ground, and whether there was a discussion around what the cost implications would be to increase the height of the panels, because obviously if you're going to move in machinery and so on, you probably want to have a bit more height, but that will come with the cost.
Yeah, no, really good question. So we have two areas. We have our main array. That main array is stock standard, and stock standard being we went for two different heights, but the panel will not go above, what was it? I think we have poles of 2.1 meters and poles of 2.5 meters, and that's basically that will be the pivot point of our east-west tracking system. Going above 2.5 meters basically required from WorkSafe that we couldn't do that with a stepladder anymore. So from a maintenance point of view, we had to use scissor lifts or cherry pickers or whatever. That, of course, we basically decided that we were not going to go for that, simply due to the fact that we didn't want those type of machinery to interfere with our crops, for starters. But the second and probably more important point, we didn't want to showcase something that was experimental. And using this experiment, we really wanted to have something that is stock standard. So the solar array that we are going to install is off the shelf. It's stock standard. So the only variation that we have, if it would have been up to the developer, they would have been stuck to 2.1 meters. We basically pushed them up to 2.5 meters to give us a little bit more height. So that is on the main array. So we haven't stock standard. On our experimental array, we will have a north-facing system, but we will be able to adjust the tilt. And basically what we do there is we are going from basically ground level up to, I think it is above 3 meters. And we will start with pasture on those panels. And because a lot of people use sheep on the panels as well. And so we want to do the research there. So that's a custom built system. Purely, and we call it also our research array rather than the main array. The main array is stock standard, so hopefully the results that we get will be applicable to the New Zealand context.
So any further questions?
Very quick one. I know it would vary a lot with the system, but do you have a rough number for the amount of meters squared required per kilowatt?
We are gonna produce 1.5 megawatts from about a 2-hectare area.
Cool, thank you.
You're welcome. And again, the difference, the distance between pole to pole, again, that was what the solar developer, because we are doing this through a power purchase agreement. And so the distance from pole to pole was being dictated basically by the developer, by the people that will actually, that we have the power purchase agreement with. So again, we are just working with what the solar developer is going to give us.
So there's no further questions. I think we'll wrap it up there. So I'd just like to thank you again, Wim, for kind of sharing this experiment with us. It sounds really interesting. So you have to update us on where things go in the future. And I really like the idea of academics taking over a project that an infrastructure project that the Lincoln University was trying to develop. So thanks a lot.
Thank you very much, Malcolm. My pleasure. Open invitation, and Ellen already knows. Ellen and myself tried to convince MB that experiments were needed within the agrivoltaics area. But if anybody that is listening either now live or to the recording, feel free to reach out, because I think collaboration is key when we try to answer these questions.
Great. Thank you.
Okay, my pleasure. Bye-bye.